Hey there guys, this is AdamantLife, and this is the first episode in my video tutorial on Python. If you haven't done so already, you can start downloading Python at python.org. Version 3.5 is the newest version, I believe, so you can go ahead and download that. Anything later will probably be alright, unless we end up in version 4, in which case it's probably not alright, but hopefully by that point I will have updated these tutorials. So there. In the meantime, while you're downloading that, I'm going to go ahead and just give you some background, and I'll give you a heads up when to pause the video in case you don't have it downloaded and installed in time. So, I've been programming for a long time now. I started way back in high school programming on TI-83. That was, I think, my first experience programming, and that was, pretty basic text-based stuff. I tried to do a little bit of a pseudo animation with scrolling screens and whatnot, but I was using the built-in programmer on the calculator, so there wasn't a whole lot that I could do, at least as far as I knew about. A few years ago, maybe 4 years ago, I started learning Java, and then shortly after that I ended up picking up Python, which is what I've been programming with for a long time now. Python itself is an object-oriented programming language, and it's designed for rapid development, which basically means that it's really easy to use. There's not a whole lot of syntax formations that you gotta keep in mind. It's all pretty simple. It varies from a lot of different programming languages in that it's white spaced based. Basically, each line of text is a new statement, and then indents indicate loops and stuff like that. Whereas in Java or C+, you would have brackets and semicolons to delineate statements, and brackets to kind of keep your text loops together. So we're not going to have to worry about that in this series. And because we don't have to worry about that, and because I've seen a lot of tutorial series on Python that start from the very basics and work your way up through really basic stuff like what's a string, what's an integer, and what are these things we can do with these, I'm actually going to run this tutorial series a little differently. So instead of starting out with the basic stuff, I'm going to go ahead and start out at kind of a broad picture on how programming kind of works and how you can kind of flow through your programming and learn it that way. So all the little stuff, like what can we do with strings and lists and integers and stuff like that, we're going to learn that stuff piecemeal along the way. But if there's something you really need to know, you can always look it up online. Google is a great resource. The Python documents are very well done. And obviously Stack Overflow, well, I shouldn't say obviously because for many of you this is going to be your first time programming, but a website called Stack Overflow has a lot of questions that have been answered over the years. So you can always go there to check as well. So there are plenty of resources if you need to find something else out. I would start with, Python documents. So just Google, Python and then your question. Check for a Python documents thing, see if you can't figure it out there, and then go over to Stack Overflow and then the rest of Google after that. That's how I would go about it. So I think we're pretty much squared away at this point, so if you need to pause to finish downloading Python, you can do that. And now that Python is downloaded for everybody, I have good old MS Paint up right here, and since we're going to be starting from the abstract, I'm going to go ahead and just use abstract images to start with, and then we'll hop into actual code in a minute. So I was thinking about it, and we'll just go ahead and start out with something pretty simple, and we're going to go ahead and use a fantasy adventurer. If you follow the rest of my YouTube page, you know that I'm into role-playing games and stuff like that. That's a horrible arm. So this is, my wheelhouse. I said that Python was object-oriented, and basically what that means is that rather than looking at things as data, we look at them as representations, lines of code as representations of things in the world. So when we talk about, our character here, which we'll call Jimmy, okay? When we talk about Jimmy, he's an object. We talk about his sword, that's an object. We give him a shield here. That's another object. And then the one more thing I'm going to add, so that we can start talking about some more basic stuff, is a backpack. make these straps look a little more like straps, since it's a stick figure. So, all these things can be objects. The trick with programming kind of is to figure out what is necessary to be an object and what isn't, because you could just be making more work for yourself by making all this stuff objects. If it doesn't really matter whether or not this sword is an object, or if it's just something that we can have in the game, or, I'm assuming game because we got an adventure here, but it could be anything. It could be a hero manager that we're working on right now. And we'll get into different examples, more mundane examples, but again, fantasy is kind of my wheelhouse, so we'll be starting there. Any of this stuff could be an object. Some of this stuff is probably better off not being an object. But for this first set of tutorials, at any rate, we're going to treat all this stuff as objects so that we can kind of get the object creation under our belt. So the one other thing we'll touch on with the drawing pad is the 3 big parts of a program. Kind of the 3 building blocks of it, so to say. And that is variables / references, functions / methods, and classes / objects. So, these are all, each line is more or less the same thing. And we'll talk about, as I get to them, what the differences are. So, a variable, alright, or a reference. Reference is the more correct term. Variable might make sense to you. So, for example, if I have 2x equals 6, right? You recognize this as a variable from math class, but really this is a reference. X equals 3, This x is referring to the number 3, and therefore we tend to call these things references instead when we're talking about Python. So basically, anytime you take something and give it a different name, like Jimmy, let's say, equals adventurer, or maybe character will be better. We'll stick with character for right now. This Jimmy is a reference, and it's the thing that we're going to be talking about, we're going to be using inside our code, but it refers specifically to a specific character. And that's why we call it a reference, because it's referring to something. Functions and methods. A function is a set of code. I'm going to go ahead and give myself a little bit more space right here. And it's set up like this. So you type in define, and then you give the function a name. I'll just call it function for now. A pair of parentheses, and then a colon, and the next line is going to be indented for spaces. Your IDE, which we'll be using idle, and I'll get to that in a second, should automatically replace this tab with 4 spaces. If it doesn't, you need to change that. Most IDEs do. Well, just in case, I'll throw that out there. There are some IDEs that will run Python code with tabs in it, but you're not supposed to have tabs in Python code. It's bad. Just saying, just bad. So this define right here just kind of indicates to the program that we're going to be creating a function. And then, like I said, function here is just our reference for the name. And then these parentheses here will hold anything that we want to pass it. So if I want to pass it x, something called x could be anything. I'm not right now validating what this x is. This opening part of the function, this first line, is just going to accept one argument, which is what we're called. It's called an argument. And it's going to create a reference to that argument and use that reference of x. I could call this anything. I could call this, character, and now I have a reference called character. So anywhere down here where I want to refer to whatever character I'm given, I will type in character. But we will just call this x for simplicity. And then a function is basically just a collection of lines of code doing stuff, and generally also a return. So if let's say we wanted to add 2 to x, so x equals x plus 2, and then divide by 2, so x equals x divided by 2. If for some reason this was important for us, for our program that we're making, we can have this here, and then we can just say, okay, function X whenever we want to do this. So like, for example, function 3 would end up giving us, how do I want to eliminate this? I'll use square brackets. Function 3 would give us 3 and 2 is 5, 5 and a half is 2.5. So that would be what we would get back from function 3. Basically, this call right here to function would be replaced by 2.5 in our code, and then whatever happens after it will just be 2.5, happening to it. And you'll see what I mean more as we go on. But just as another example, if we use 8, that'd be 5. So you can see, 8 comes in here, 8 becomes x, x plus 2 is 10, 10 divided by 2 is 5, and then we return, which just means, go back to the code you were working on, and wherever function appeared, replace it with this value of x. So this function in our code, if I say, if function 8 is less than 10, if I have this if this if clause right here, this would actually turn into, when the program is run, if 5 is less than 10, and then, because it's true, it would execute some code down here. We'll talk more about if and else clauses and different kinds of for loops and stuff like that as we go along. But for now, yeah, you understand what functions are. A method. Methods are just functions. That's just a specialized term to refer to functions that belong to a class. So now we'll just talk about classes. Clear this stuff out. A class is basically a collection of information and functions that objects have. So when we create Jimmy in this world, we'll be creating a Jimmy object. It will be a Jimmy, Jimmy will be an object, alright? He'll be a character object. That's probably what we're going to be doing. So doing this right here will create an object. And I will show you the code behind that now, because that's going to look exactly like a function to you as is. So to create a class, we use this word class right here to tell the code that we're creating a class. We're going to name the class character, parentheses, and a colon. Again, this should look exactly like a function to you. The difference being that this is class instead of def or define. Otherwise, class name right here. And then we'll talk about this, because this doesn't actually take arguments like a function does. Instead, what takes arguments is this next line. Okay? So, if you're following along, def, define here, is a function. That should, the second you see def, you say, okay, this is a function. And because it's indented here, this is a special function that belongs just to character objects. That's what that means, because it's inside the class. This name right here, because remember, our functions go define, and then the function name, and then arguments. This is a special reserved function for objects that says when we create a new object. So, for example, this class could actually make multiple Jimmies. Theoretically, it could make multiple Jimmies. We'll probably only be making one Jimmy, but, if this was, if we were making goblins out of this class, maybe we do want 10 goblins. So each goblin object instance gets created using this function right here. And this function is basically going to set up what kind of, what data, basically, most of the time, this character has. So, if I'm going to go ahead and change this X to name, and let me just stretch this out so that we can have that on one line. Maybe a little less. There we go. So, self here means that this is going to be an instance. That's what this means, so we don't actually have to touch this. Basically, when class gets initiated, it will pass a new instance to this function. So you don't actually have to do anything for that. And then name obviously is no different from, when we did define function x. That's exactly like this. We're getting something, we don't know what it is at this point, but we're going to refer to it as name, kind of like we referred to, 8 as x. And then down here, we're going to do something like self.name equals name. That's an example of something we might do in this function, where we set this character instance. I'll go ahead and add instance up here as well. So, all things are objects. All things created from classes are objects. And then an instance is just the term we use to refer to a specific object. So if I had 10 blue marbles, that an instance would be one of those blue marbles. Like if I took a marker and marked that blue marble with a red, X on it, then that red X marble I could identify as a specific instance of blue marbles. For example, this right here, this dot, the period, means that this reference right here belongs to the thing before it. And again, this self is a reference to this instance. So name is a reference to information that belongs to this instance. Dot, this belongs to this. And then name here obviously is probably like, we probably gave it Jimmy or something like that, So that name gets replaced with Jimmy when all said is done. And then classes get created, object instances get created the same exact way as functions. We're just going to say character and then Jimmy. And the quotes in here mean that this is a word. That's when you heard me say string earlier. Strings are words, and we use single or double quotes, which I'll explain if it ever comes up. The differences between those. They basically function the same exact way, so you don't actually have to worry about it, but most people will feel more comfortable using double quotes. I'll explain how and when it might be beneficial to use single quotes. And that covers the 3 different things that we had. So, references are, basically short names, in the code for other things. Functions are groups of code that serve a purpose, and then classes are, things. They're Jimmy, a character, for example. So, that gets us more or less everything nailed down. So, if you have Python installed now, we're good to move on. Otherwise, you're going to want to pause the video and make sure that's installed. Alright, so, now that everybody has Python installed, I mentioned this earlier, we're going to be using IDE. It comes packaged with Python, so you don't have to go download it. You just gotta type in idle, IDLE, into, well, I'm assuming that you're going to hit Windows key and then search for idle. Otherwise, however you go about searching your computer, search for idle. It's a very simple IDE, which is an IDE is just like kind of a text pad that's going to highlight stuff and help keep us organized and do a couple of short cut functions for us. There are definitely more powerful IDEs out there. For example, Visual Studio or Eclipse are 2 other ones that you might decide to use, but for the purposes of this tutorial, idle has plenty enough functionality that we'll be fine just using it. And it saves us the trouble of downloading and installing other stuff. So this left-hand screen right here is the shell. This should pop right up when you click idle. And then you can go ahead and hit Control-N to bring up a new Python file. And then just really quick save that so that you don't have to name it later. Save it to your desktop or wherever you feel like storing this. So, to get things underway, we have our tools, that we've talked about. So let's get started. Our goal right now, hashtags, by the way, are comments. If you need multiple lines commented, you can use 2 pairs of triple quotes, or I'm sorry, you can use triple quotes. So that, or 3 single quotes, whichever works. And then anything in between that will just be a string, and that more or less functions as a comment. You know, the computer isn't going to interpret that as anything really. So there you go. Those are 2 different ways of commenting. So our goals right now is to create Jimmy. And it's important to kind of keep, when you're programming, to keep everything like within a scope that you can focus on. If you start burying yourself in all the stuff that you have to get done, it becomes really easy just to get lost and like go off on tangents doing stuff. You should try to keep focused on this stuff, and it's one of those things, the more you program, the better you'll get at juggling multiple things at once. But for now, our goal is just to create Jimmy. So to do that, we're going to need a class. And as I mentioned, we're going to be using character. That way it's generic enough. And you can see right here, let me go ahead and configure idle. Make this a bit bigger for you so that you can see it easier. There we go. That should show up easier. That way I don't have to do any post editing. So we've got our class, and you can see I hit enter and it automatically indented for me. You know, that's the joy of using an IDE. And then if you remember correctly from a couple minutes ago, define init, or initiation is what that stands for, I'm pretty sure. Self, and again, we're just going to use this example of name. And then self.name equals name. So this is what we just did before, right? So how do we go about using this is the real question. We have our class, how do we do that? Well, very simply, we, in the strictest sense, we can just say character name equals Jimmy and close it like that. And in the strictest sense, that does exactly what we wanted to do. We have created Jimmy. Unfortunately, we have no way in further, anywhere down here to refer to this. So the next thing we got to do is create a reference to Jimmy. So we do that by using the equals sign. So Jimmy equals character. And all of 45 seconds later, you have successfully created a character. Most RPGs, creating a character takes an hour. You just did it in 10 seconds. So, yeah. This may seem really simple and unuseful, but it actually contains most of everything that you need to know. We have a class, we have functions, we have successfully used a function. Oh, one thing I will note is that you'll recall that we had return in functions. If you step down from a function, so, if we come down to this level at any rate, then that closes the function automatically, and the Python, when it runs this code, is going to basically insert return none here. That's basically what's going to happen. So we don't always have to return, though it is useful and correct on most functions to have a return. But in case we don't, it's automatically going to insert return none when it steps out. So now we can kind of start working with Jimmy and deciding other things and different aspects of Jimmy. So we said we're going to create everything in object. So if we hop back over here, we can see that Jimmy also had a sword and a shield and a backpack. So we're going to go ahead and for this first episode, we're going to go ahead and hammer those things out. So class, right? We want to create objects, so we want to create class. So here's a question. What are these things? Very obviously, we can go ahead and say class sword, define init self name self.name equals name, and all of a sudden, Jimmy dot sword equals equals sword name equals bronze sword. This works. We don't necessarily need to overcomplicate things right now, so this class of sword, with this class, which is a sword class, has a name, which is bronze sword, and now, again, the period, so this thing after the period belongs to the thing before the period. So this reference of sword belongs to Jimmy, so now Jimmy's sword is a sword object, which we created here. I'll go ahead and just pop this up here, in case it's confusing anybody. Sword object, and then we're going to just take that and tack that onto there. The other way we can do this, let me just copy these. Save myself a little bit of typing. Shield. The other way we can think about doing it is shield equals shield name silver shield, because he has a better shield than he has a sword. And then Jimmy dot shield equals shield. So what's this doing here? Remember that references are just kind of replacing things. So this shield here gets replaced by this information right here. All this information in the shield class, as well as any information determined in the initiate function or method, if I want to be more specific. So that gets replaced here, and then this gets replaced down here. Actually, I'll just do that. So this right here is what's going on here. I'll just comment that out. So far we've used a few different ways to create Jimmy, and then we gave Jimmy a sword just by assigning the sword directly to a sword reference on Jimmy. Or we created a shield, gave that shield its own reference, and then chained that reference to a shield reference on Jimmy. We could also, his shield, it doesn't matter, just in case you're getting stuck up on names. Doesn't matter. It doesn't have to match at all, for the record. And then he has one more thing. He has a backpack. The third way we can do this is remember that any information given to the initiate function gets, passed along. So backpack, we can say he has a backpack. And then I'll just copy this down to save myself some typing time. Backpack. So the third way we can do this is when we create Jimmy, character name equals Jimmy. Backpack equals backpack. Leather backpack. And then we make sure to close all our make this bigger for us so we can get it all in one line. And then we just make sure to close all our parentheses. You can see that idle EDE will show you where the parentheses are closing when you do this. So that closes there, that closes there. It varies from IDE to IDE how much it shows you. For example, it may just highlight the parentheses like that, when I close this one. And then Jimmy, if I, say print Jimmy dot backpack, actually, let's fix that. Self dot backpack equals backpack. There you go. So now when I call Jimmy that backpack, it will print. What it will actually print is a backpack object. It will say backpack object at memory location, which is not something you need to know about at all. Not anytime soon at any rate. But really it should be, well, I'll ask you, what should this be? If I want to print out Jimmy's backpack's name, what should I type in? And the answer is I should be typing in jimmy.backpack.name. And that will print out leather backpack. Again, this right here, this thing, gets turned into Jimmy equals character, name equals Jimmy, backpack equals, I'm just going to say backpack object, and then that in turn gets turned into Jimmy equals character, character object. Yeah. So there we go. We have successfully, in this first episode, created classes of objects, created instances of objects in a couple different fashions, and assigned values to those objects. Obviously, this is all super simple at this point, but in future episodes, we're going to go ahead and fill this out, and before the end of it, we'll have a fairly complex and useful set of code, because we're not actually going to finish a game or anything like that. Again, this is supposed to get you programming quickly so that you can do stuff like that. But we will have this filled out to be extremely useful and have you ready to go in no time. So, thank you for watching. Like, favorite, subscribe, please. And look forward to the next episode of this series where we'll be, I think we'll go into backpack and start figuring out what backpack is. So, that will be fun. Have a wonderful evening, day, afternoon, wherever you're at in the world, and I will catch you next time.